The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Okay, this will take a little bit different direction. I'm going to talk to you today, and it's going to be kind of brief, about BIM implementation by the concrete contractor. And before we get going, there's really a couple takeaways that I want you to be able to leave here. Is why should a concrete contractor use BIM? And the bottom line is because internal and external workflow advantages are improved to an extent where it improves your quality, performance, and profitability. Little background on our company. Klorman Construction was established in 1980. We're a design-build general contractor. We're one of the largest concrete contractors in the country. We started using virtual design and construction, or BIM, on all of our projects since 2005, so we've modeled quite a few buildings in the last 10 years and built all of them from the model. We're recognized as one of the leading VDC companies in North America. We were fortunate enough back in 2011 to get the runner-up for Tekla's North American BIM Awards. Our experience is based on all real-world projects. 2011, we were inducted into Meridian's Hall of Fame for recognition of best-in-class management. In 2012, 13, and 14, we were awarded the ConstructTech Vision Award Gold Medal for applying technologies to our everyday businesses. 2013, ENR, we had the best project for airport transit, new projects for the Tom Bradley International Terminal at LAX. And in 2014, CRSI Honor Award for leadership in reinforced concrete structures. So what I want to really talk to you today about is business practice and workflows. And so the way Klorman works, everything starts at a model. So from the model, we have two different ways we go. We go pursuit, or you may think of it as sales, and we go to field operations or construction. So in pursuit, we do two types of projects. We do design build, and we do plans and specs. We're a hard dollar contractor. We don't do anything negotiated. We don't do any GMAX projects. From construction, we go into our project controls. In plans and spec work or design build, we start with the early modeling and early planning. We go into model-based quantity takeoffs, and we go into our presentation works to sell the project. From our construction side, we go straight into quality control, safety, cost control. Out of our quality control side, we run our constructability reviews, our 4D validations and simulations, our fit-up reviews, and our as-built versus as-planned. In cost control, handles all of our resource management, our scheduling, and our change order management. We move to material utilization, labor utilization, and our prefabrication. And prefabrication, for today's conversation, is specifically for prefabricated formwork and all of our reinforcing steel. We're not only a concrete contractor, but we're a very large rebar fabricator and installer. So today, because of the very limited amount of time, I'm going to try and capture a little bit on the upper side of sales and pursuit. We'll give you a little bit of background through the construction phase for some validations and control. All of these is important to understand that they tie to each other. So whatever we do in pursuit and sales, that immediately gets pushed into the construction models, which then gets pushed into all of our cost control work. And unfortunately, there's not enough time, but there's huge, huge dollar savings for the company in that workflow. And what I mean by the difference of the two is, at the upper side, when you're selling work, there has to be an ability to capture some resale value that you give to the client. And so these really end up going back, because you're competitive. I want to beat you, you want to beat me. You're going to give the owner what your savings are. So these end up going back to the owner. These really help you sell the work. This is what you put in your back pocket. This cuts down your workflow of your detailers, redundancy, duplication of steps of work, and there's a huge streamlining effect. So, little idea of pursuit modeling. This is a plans and spec parking structure. It's about 5,000 cars out in Riverside. that we did, one of the advantages for us against our competition is, of course, they were using 2D drawings. So we can bring the 2D drawings to life, and in this case, we were able to simulate different skins on this building. There's a very elaborate precast facade that had to go on the outside, and we were able to show the owner different ways of doing that without having them to spend the money to have their A&E firm do it for us. This is a design-build parking structure where we were trying to explain to the client very unusual circumstances for the framing on the far end of the building, how our form systems would work, safety issues, how it would work, and even to the CEO's position of sitting in the office or in his parking stall, seeing what it would look at. But you can see the amount of form work, everything gets detailed into these models and then goes down into the construction model. This is a bridge project that we're involved in. This is the cable stay section of the bridge. But what was really interesting for this part of the sales program was this is the about 5 miles of box girder approach slabs, and you'll see this little red train track here. I don't know if you know much about exports out of ports, but the biggest export in this country is scrap. And so you can't at a port stop the scrap export from going on. So we were able to go in and look at the problems that were associated with this, keeping this rail in place, and the problems that we had run into in construction. And from all the civil drawings, that couldn't be determined, but by being able to do this and present it, we were able to prove that we understand the idiosyncrasies of the project better than our competition. This is another pursuit, but this is a simulation of how we're going to build the building. You may have seen these before where we tie it to the construction schedule. This is a project in Washington, D.C. It's actually an embassy. And we were explaining that we had to keep the existing facade for historical reasons. They needed to understand how we would go through and excavate and do the OX and shoring, and then from there, how we would actually build the building per the sequence. So you can see it's tied to the actual construction schedule. What's in red is what's being built. What's in white is the as cast. But very powerful from a sales program to be able to walk in. And not only is it powerful in what you're telling the client you know, is that because we have all this information, we're pushing it downstream through our entire company, and we're able to take total advantage of it, understanding what our actual costs are. We've tied all of our formwork systems. Everything that we do is tied to a database with consumption rates, productivity rates. So at this point of the presentation, we already have been able to do what-if scenarios on form systems. We know if, depending which form system we use, what the cost is going to be. It's tied to our databases, so we know from inventory control if we have to rent it, if we have to buy it, if we have to fabricate it. So we're miles ahead at the beginning of the sales process than you would be in the old 2D world. Keeping with that, give you a little, just a brief shot of going into taking that model and moving it into cost planning. We're not going to really talk much about scheduling, there's no time. But what you're looking at, this is a project of ours in Los Angeles, California. It's 2 towers and a parking structure. And you can see that the model was modeled in Tekla. We brought it into another platform. And because the model is organized by elements, you can see we have each element captured. And of course, we can do the simple things of highlighting it. And then when we expand that, we can see the data quantity types that are associated with that specific piece of, or that specific building element. Of course, because we can look at it, we can also isolate it. We can go in and do studies. We can go back and consider, how do we want to form this? Is it going to be a climbing form, by crane, self-climbing form? What's our best way to work with it? Another thing, as Pete was touching on, is version control. Because we have model-based information, we can look at the different versions. Not only does it help us for change management down the road, but it helps us at the sales level. Now, because it's all brought into the model, not only can we do takeoff from the model, but we can now do our cost planning directly from the model. So this is set up in a Uni Format 2 basis. And if we drill down into the model, you'll see in the superstructure, we can keep drilling down. Every level of detail has all the way down to the most granular level of cost, which is what we call ELMOs, labor, material, equipment, subcontractors, and others. And you can see they're at their various unit of measure types, whether it's by hour, by square foot, and then they all roll up to the parent level at a square foot. So we can go back and double check our costing based on our standards. And not just because we have that, we don't have to look at it only in 2D. We can now go back and look at it side by side with the model. And as we drill down into the cost plan, we can highlight any particular element that we've cost planned and go back and see if our assumptions are right, that the type of labor we've assigned to it or material that we've assigned to it makes sense. Another great advantage, because it's in the model, is now we can go, instead of just floor by floor, we can do location-based management. So here we've taken this building, we've initially divided it into 3. We've got the parking structure, the east tower and the west tower. And when we turn that up, not only do we have the 3 locations, but now we've subdivided it by floor, so we can control the model and all the information that we have per floor. We can actually go in even farther and develop that into individual isolated areas. But again, because we're able to control the model, we can go in, isolate one particular floor. Here we've turned off all the finished trades and the skin. But another nice feature, which I don't show you here, is we can actually bring in the 2D model and overlay this on this 3D model to double check if we've missed anything in our preparation of our takeoff. And so if we go back and look at the overall model, you'll notice also as we switch through the models, each tower has a different floor height, including the parking structure. And so we're not limited by having one universal plane. We have multiple planes within the multiple vertical boxes. And so now that we have all this information about the model and based on location and based on building unit element, instead of simply looking at the model on a global basis, we can go in and look at it by location. So we're looking at shear walls, there's none in the garage, but as we scroll over, now we have that information at every single floor of the east tower and the west tower in the different quantity data types that we need to be able to develop our pricing structure. And so that's kind of a real quick overview of being able to use model-based quantity takeoffs. A little on some more project controls. This is the bridge project you were looking at earlier. This is to give you an idea of just how heavy these projects are. This pad, or this pile cap, is 40 foot square. That's a 6 foot tall man, to give you an idea of scale. Every bar is modeled. There's 8 layers of number 18 bars on the bottom. There's 8 layers of 14 and 18 bar on the top. And there's almost 6,000 hairpins that go into this mat. And you can see every single one is detailed. So in order to explain to the owner how we were going to build this, it's a secret. So we did another type of a validation. And here you can see we've gone through the steps. The crush rings come off. We go in with the support systems that come in to carry the first layers of the mats. Then we'll have all the multiple layers of mats that go in. Sorry, it should be a little bit faster, but they had to downside this file for the model or for the presentation. So you'll see it's going to step through all of the different layers that go through. The important part is going to come into how do you carry at 14 feet deep? How do you carry the top 8 layers of steel? And you've got a 515 foot tall bed that goes on top of this. So by doing the sequencing, we were able to figure out how to weld up our ladder that was going to support that center tower for the first lift. And then we were able to figure out how to weld our ladders to carry the upper steel mesh. And then it also gave us the ability to look at the different layering systems to make it buildable so a man can stand on top of it. Didn't work with the layering sequence that the design professional had come up with. So we were able to go back and work with them on changing the layers of the mats so that it was buildable. And again, there's no way you can do this at this level of understanding for a number of people in a room by doing it with 2D drawings and do it in the time frame that you can do it in. And I'm just waiting for the big ocean wave because I think it's the best part of it when all the hairpins fall in. A little slow on the video. It's much more impressive when it's quicker, sorry. Give you one more validation program. Now, you've seen how you can validate a sequence of construction and a schedule. But what's super important to us is validating a very specific activity. In this project, we had 2 problems. crane can only lift from 2 sides of the project. We had to convince the owner we could do a floor in a week. So we developed this self-climbing core system, and this is actually tied to a schedule that shows all of the actual crews, the number of man hours, the amount of material, the amount of pumps that'll be on the job at the same time, and it develops this presentation. So the columns get poured, we strip, and now the big problem is how do you cycle these tables? And we had to use tables. We couldn't use column-mounted form systems because of the 2 lifts and the limitations of the crane. So this gave us the ability to really go back through and vet out how these systems will fly. Will they work with the owner's provided tower crane, which is always a battle for us. If we don't provide the tower crane, owners tend to want to use a smaller crane that doesn't give us the capacity. But you can see it becomes very complex of how we move the tables across, moving the safety equipment with them, and then feeding all of the tables underneath the building to get out to the pick points. Now, one of the things you'll also notice is that there's all the void spaces. If you're going to model something, you need to model it what we call anatomically correct, exactly how it would be built. Well, these columns are in the way. These tables would not fly with solid form systems. So what happens is we were able to account for the amount of labor that had to come back and do the hand sets to fill these in. So again, it's trying to take away all the guesswork and get all the input from all of our players or stakeholders. So when the handset system comes in and they start doing the infill, the table crew finishes up. The table crew is going to move down and they're going to start moving the reshores back up. So every step that it takes to build this building to get ready to make the pour have been accounted for, and then it's a monolithic pour with the core walls, and we jump the form one more time. So completely validated by not only 2D data, but by 3D data to be able to convince the owner that it's been taken care of. And then, of course, it would play out to its normal finish. Logistics and safety. This happens to be a large parking structure in California, and the green buildings were the existing structures. The blue buildings are the new part of the development. This actual building here turns out to be a Costco, so there was a very definite deliverable date that the developer had to meet in order to open up Costco and not lose a major anchor. So one of the problems for us was to understand the logistics of, because this is a 4-bay garage, how we could reach it, why construction was moving to us. And so we were able to time out the delivery of this side of the building, and then we would move to a spider placing mechanism. But again, being able to coordinate that is a big help. Other site safety and logistics, you can see all of our formwork is modeled in all of the projects. Here you're looking at the finished structure, barrier cables, all the way up to the structure being built. We had unusual situations where this top floor cantilevered out, so we had to understand the equipment we would use to carry that last beam. And then you can see we have bolt-on column-mounted brackets to carry a steel girder that would help support the outside. Not only is all of this in the model, but every bit of this ties to a bill of material. It's all understood. We know every single piece down to the individual nut and bolt that it takes. We also have waste factors built in, so we know what the plywood requirements are going to be. If it's an architectural exposed element, it's double layered, back screwed. All of that is contained in our inventory. Same with precise grading and excavation. This particular project had a tunnel that had to come in to the underground part of the structure, and so you can see we've already got the gang forms sequenced into the perimeter. All the column clamps are on the column, and we're able to coordinate what it's going to take to make sure we have enough over excavation for the deepened pads. Some quality control and transparency advantages. We've tied everything to a web-based solution, so this is our Klorman Converge, which is an engine that's run off of Converge through Meridian. It's a Trimble product called Prologue. And so depending on your security level, you can get in and look at different parts of the project. But what we've done, which is a very important workflow to understand, is in order to have consistency, we've completely remapped how our field and our offices work. So everything that the field is going to do to build the building starts from the BIM model from our VDC end. And so whether you're looking at getting foundations or columns or slabs in, it starts with the model. The field comes back to the BIM department of where they're going to start on the building, what control they need, and what layout they need for the RTS. we produce it back for them. And then every step along the way, whether they provide the area casting, we produce the formwork and fabrication and shop drawings, which are ultimately used for the fab shops, for the fabrication, erection, quantity takeoffs, and as they go through. So everything is very deliberate. It works through every single sequence of the project. And because we use the BIM to that level, little advantages that you get. In this situation, we use the BIM as our repository. And every RFI that's recorded on the project is recorded in the model. So when we, with the push of a button, look at the building in plan view, we can see these are 60-foot sections of wall. How many RFIs have been written for those specific sections of the building? Now, that happens to be from the Tom Bradley International Terminal. That job had 989 change orders on the job, and we had over 11,000 RFIs on that project in 3.5 years. We had $70 million in change orders just for the concrete work alone. So, you know, having a database that you can query on the fly for change order management is a huge capability. The other thing is it makes certain that your field people are up to date. There's no longer a situation of, are we laying out to the most current document? Nobody does anything without querying the model first. Some tolerance, control, and fit up. This is something that's pretty near and dear to me. Everybody talks about BIM, and BIM is usually drawn in 100% accuracy, doesn't take into tolerances, but in the real world, when we build stuff, we have tolerance issues. So how do you push that back to the model? Now, Pete showed a little bit of a robotic total station. This is an older version. For those of you that haven't seen it, this is just a very short little video to give you an idea of how it works. So what you're looking at, that's an LM80 little handheld computer, and it has Wi-Fi on it and email, and it's talking to the robotic total station. You can see it wave to you. What we do through the model is we establish all the control points for all of the layout. All of that layout is contained inside that computer. So the party chief, as soon as there's a revision to the layout, it's updated automatically, so we're always laying out the most current building. That's what he's looking at in the old version, not like the new field links, but those are all his control points. As soon as we pour, an engineer goes out and we shoot every single anchor bolt, or we shoot vertical plumb, we shoot rustification strips and reveals. That's transferred back into the model, and what you're seeing here is that the yellow spheres are the actual as-planned layout of the anchor bolts. The salmon color spheres are the actual direct reads. We've elevated them just so you can see them in the model. But what that does is literally we produce a tolerance report. So we know what our coordinates were, we know what code section we're under, we've defined what tolerances are for the specific job, whether the steel tolerance prevails or the concrete tolerances prevail. And then we run the report, and you can see here most of the work is accurate, but we have 3 that are out of tolerances. So within 24 hours of pouring concrete, we know exactly where we have errors on the job. And how do you resolve that? Do you go out and fix the anchor bolt location? Do you go to the steel contractor because he hasn't fabricated yet and adjust it in the field? This little step that we've added has saved us $400,000 a year in repair and back charge costs from structural steel contractors. And then, of course, the same is done. This happens to be a 100-foot tall architectural wall. It was freestanding, but you can see there's a tremendous amount of anchorage for a steel structure that ties to it after we were done. Same thing, as built it, we're able to handle the coordinates. This is all metal slabs that we do. Before we pour and after we pour, we do 3D laser scanning. We can compare that to as-builts. This job we found a mistake. Before we pour a slab, this happens to be a job where we had an argument. We didn't provide the PT and rebar, so we scanned it before the pour. After the concrete, we were able to establish by color levels what was green was acceptable, yellow was at tolerance, and red was out of tolerance. Goes to and just to kind of wrap things up in the last part of it, as built in existing conditions. This is a project we were brought in on. We 3D scanned the entire project. These are all destructive testing locations. So we were able to take, that's actually from the 3D scanner. Here's what it should have looked like. That's what it actually was built to. But what gets more fun about it, this is an elevator lobby. You can see all of the steel's been heated and bent over. And so when we went in and we scanned this, we were able to produce the as-built model, produce what it should have looked like, merge the two together so you can see what was built versus what should have been built. But then we did 3D rapid prototype printing like Pete was showing. And so you can see that that model is absolutely perfect down to the irregularities in the concrete, but you can see how that steel was bent. And so we did a number of those just to give you an idea. This is a shear wall condition. This is what was on the rebar detailer shop drawings. That's what was actually built. And you can see it's a pretty powerful piece to be able to hold in your hand and look at and understand what actually happened. And so, you can do all sorts of measuring, and I'm running out of time. The nice thing is you can split the building. Here we're able to look at below this floor and above this floor. Here's the reinforcing steel that's too close to the exterior surface of this wall, and here's what the layout is at the floor above. So, you have huge capabilities with what technology and integrating technology has given us today. And with that, I can tell you that building information modeling definitely improves your quality, performance, and profitability.